In long-distance races, performance greatly depends on the capability of the swimmer to perform ideal swim turns. The swim turn will begin when the swimmer is approaching the wall approximately 5 meters before reaching, and it will end when the head reaches the 10 meter. The importance of this is that with an improvement in turning will decrease the overall race time. As Koster says, freestyle turns comprise 20.5% of the total race time in a 50 meters race in a short course pool, and an even greater contribution has been reported for longer races. The swim turn has 6 phases in order to execute an efficient turn. First, it will be the approach phase, followed by the rotation phase, and then the wall contact phase. In fourth place will be the glide phase, followed by the stroke preparation phase, and at the end, the stroke resumption phase. The methodology will consist of 4 athletes, 2 male and 2 female, whose ages varied between 19 and 23 years. They were divided into 2 groups, and the swimmers that we analyzed were the ones in the left. They will swim from the 10-meter mark towards the wall and perform the turn at a normal pace. The methods and procedures will consist on an underwater analysis made by underwater cameras as main equipment, 2 positions, one at the bottom of the pool and one at the side. Also, we will be making a 3D and 2D analysis with the SkillSpectre. In the left, we can see the lateral camera positioned at 0.8 meters away from the wall, and then at the right, the depth of the pool can show the distance from the underwater camera to the surface. In this picture, you can observe the positioning calibration structure.
To facilitate detailed assessment of a swimmer's strengths and weaknesses and allow different turning techniques to be compared, the determination of the following variables was made. First, we have the velocity while approaching the wall. Next, the head positioning while approaching the wall. Following, we have the streamline before pushing the wall. Next, we have the wall contact time and the velocity leaving the wall. And lastly, we have the glide time and the underwater kicking. The first variable is measuring the velocity. The velocity is important because, as Koster points out, the average velocity out from the wall after the turn and the total velocity were significantly correlated with the event time. Entry and exit velocities were measured using the software SkillSpectre, using 2D analysis and by marking the head throughout the turn, as it approached and left the wall. The next variable is head positioning. Proper head positioning while approaching the wall plays a vital role in determining the efficiency of a turn. One of the best indicators of turn performance is the place where the rotation begins. To initiate the rotation further from the wall, the head should be tucked in. Head positioning was analyzed using the lateral videos and tracking the head, making sure it followed the right path with the software Richimas. The third variable is the wall contact time. The approximate time spent on the wall during a turn is 0.3 to 0.5 seconds. This will be measured as the time the feet stay in contact with the wall, with the help of SkillSpectre. And lastly, we have underwater kicking. The underwater range covered by the cameras was insufficient to measure this variable. Overall, the range covered by the cameras was approximately only 1.5 meters away from the wall. The following results were obtained. By analyzing in 2D on SkillSpectre, we obtain a velocity graph, in which the x-axis represents the time measured in seconds and the y-axis represents the velocity measured in meters per second. The videos for measuring the velocity were the ones taken from the side, and the axis in which the velocity was tracked was the horizontal axis, or the axis in which the swimmer approached the wall. For the male athlete, we can see the following graph. This is the evolution of the velocity of the head as the turn takes place. His entry velocity is 1.20 meters and his exit velocity is 3.18 meters. For the female athlete, the following graph was displayed. Her entry velocity was 1.48 meters and her exit velocity was 3.16 meters. For our second variable, the following graphs show the path the head follows as the swimmer approaches the wall. The data obtained was with the help of the software Richimas. The x-axis represents the horizontal coordinates or the distance to the wall, and the y-axis represents the vertical coordinates or the pool depth. The different points are taken 10 frames apart. The blue one shows the position of the head of the male swimmer as he approaches the wall, and the orange one shows the position of the female swimmer's head as she approaches the wall.
The data obtained suggests that the male swimmer lifts his head before initiating the turn. This behavior should be avoided because it creates unnecessary drag before starting the turn. The female swimmer has a better starting point, but towards the end of the turn her head is more elevated, delaying her and making it harder to push on a drag-free streamline position. On the contrary, the male swimmer keeps his head lower, making it easier for himself to align with his shoulder and hip. To obtain this data, the videos were digitalized on 2D in Scale Spectre. With the position graph and by seeing carefully the video, we recorded the time at which the swimmer feet touched the wall and the moment right after the push. Subtracting those times and by averaging both videos for each male and female athlete, the results were: for the female swimmer average contact time was 0.36 seconds and for the female swimmer average contact time was 0.46 seconds. By combining the results obtained, we obtained the following graph. Both swimmers start to tuck their heads in a proper distance before reaching the wall. Male swimmer initiates first due to his body weight. The first variable of the table depends on each subject's height, and this will depend his or her comfortability. Relation with their own space, T's and marks painted in the pool. Position of sight can make an improvement for head trajectories. The second variable shown in the graph states the time the feet were in contact with the wall during their turn. This can help shave a few milliseconds of racing time if done properly. The stage goal is the time in contact with the wall is minimal. The wall is a place where you can acquire important advantage on a race. The average time could be in between 0.3 seconds and 0.5 seconds. The final variables in the graph are the entry and exit velocities. The exit velocity is twice as fast as the entry one. The exit velocities depend largely on making a nearly perfect streamline to avoid all unnecessary drag resistance from the water. Accelerating towards the wall generates more momentum so that the turn can be done faster. For the summary conclusions, clear returns are highly crucial when determining the overall performance of a swimmer, especially in long-distance races. The best flip turns have one common characteristic: long head wall distance where the rotation starts. Also, the time spent in contact with the wall is periodical if it is high. The present study shows in what areas each individual swimmer may improve, and even though there are many variables that matter to optimize the time to make a flip turn, with the advice of the coach and the research done, the variables that are important for swimmers were clear and concise.